So today we're going to talk about percentage composition, which is a pretty straightforward concept. We're just talking about how much stuff of the individual elements represents parts of a whole. So let's say that you had some kind of fruit basket and it had apples and oranges and bananas. If you knew the weight of each of these and the mass, then you would just take the weight of the apples and divide that by the weight of the entire basket to figure out what percentage of that, actually, of the mass of the basket, actually represented the mass of the apples. So we're going to do the same kind of thing. We're just going to be doing it with compounds. So here's a pretty straightforward example. We've got 2.5 grams of hydrogen. There's a certain amount of oxygen. And in total, it makes 22.5 grams of water. So we just need to figure out what's the percentage of hydrogen and oxygen in that 22.5 grams. So we could do oxygen one of two ways. First off, we're going to do hydrogen, though. So the percentage of hydrogen is going to be equal to the actual amount of hydrogen, so the weight of it, which is grams, and then the total amount. And we're going to times that by 100% to be able to give us this percentage. So if we do that and we crunch in the numbers, I'm going to move two significant digits here because we've got two significant digits in the top one. So that's going to be 11%. Now for oxygen, I can go about one of two ways. First way is that I know that whatever the mass of oxygen is going to be will be 22.5 minus 2.5. So I might find out that the mass of oxygen is actually going to be 20 grams. Or I can also just take a look at this. Because there's only two elements, I know that they've got to add up to 100%. And so I'm either going to subtract the hydrogen from the total to just figure out the oxygen, divide that by the total, times it by 100%, and that's going to be giving me 89%. Or I can just take 100 and then subtract the 11. Okay, so hopefully that was a pretty straightforward, easy to do situation where all we're trying to do is take the amount that represents each individual element. So our percentage composition is going to be equal to our individual element over our total mass. Okay, so that's when we are given masses and we're working with masses, but we may not always have that situation. So let's look at another situation. So let's say instead we are given this compound and we need to find out what the total is for each element. So how much of this compound, how much of it is hydrogen, how much of it is sulfur, how much of it is oxygen. So the first thing that we want to do is actually just calculate out the molar masses for each of those elements. And we use our trusty periodic table for that. So the molar mass of our sulfuric acid, I'm not going to bother putting the AQ when we put it as a subscript there, is going to be equal to, so we have two hydrogens, so 2 times 1.0079 plus sulfur, which is 32.065, plus 4 times our oxygen, which is 15.9994. Okay? So the same thing that we've done before with molar mass. Adding all of these things up really quickly on the calculator. Maybe a little bit faster for you. I just made a mistake on mine. Okay, so I get the total of 98.07 0.84. I'm just going to keep all of those decimal places in there because I just want to make sure that I'm not rounding off too early. Okay, so this is my total amount for 1 mole of this compound. But I can take a look at these individual amounts to figure out how much mass each represents. So, looking at the hydrogen, we're going to be doing the same kind of thing that we did before, where hydrogen, so our molar mass of the hydrogen by itself is going to be that 2 times. So the same thing that we did in order to get the mass. So sorry, that should be a little m for our actual mass. So hydrogen is going to be 2 times 1.0079, which is 2.0158 grams. Our sulfur, we're just going to plug in the number that is there, 32.065 grams. And then oxygen is going to be equal to 4 times, since we have 4. So always just make sure that you're multiplying it by the amount of that element that you have inside of the compound, so that you are making sure that you're not forgetting anything out. Okay, so 63.9976. And so when I'm translating this into percentages, doing the same thing that I did before. So here I've got the mass of the element, which is hydrogen here, divided by the total mass. And for us, the total mass right now is going to be our molar mass. So we're going to take that as a mass times 100%, which will be we'll just pretend that I'm taking some extra time to calculate everything so that you can calculate along with me. All right, and we times this by 100%, so I get 0.02 times 100% means that hydrogen's about 2%. 2.055. And we have a 3 there. Percent. Okay, so that's a percentage of hydrogen. For sulfur, so the percentage of sulfur is going to be equal to just our regular 32.065 grams divided by our total molar mass. So that's going to be equal to 32.693%. And just a little bit, if you're wondering why I'm keeping my percentages that long, it's just because I'm using significant digits. So here with sulfur, we've got 5 significant digits. So we definitely have more than that for the molar mass. So I'm going to make sure my answer has 5 significant digits. Okay, and lastly, we've got our oxygen. So we've got that over our total amount. And you can plug this in along with me as I'm calculating. Again, if you wanted to, you could always just subtract this from the total. So if you got 100, you could subtract that, and then what you get here would be left over. So for us, this is going to be, oops, almost forgot to say, times 100%. Make sure you're timesing it by 100%. So here we're going to get 65.251 grams. Okay, so here we can use the molar masses and then just how much we have in each one of those to be able to find out what percentage composition by mass we have of each element inside of a compound. Hopefully that was pretty straightforward. Again, just try and think of this not necessarily as just chemistry stuff, but just as everyday thing. You'd be using this in a lot of different situations as well, if you happen to count up fruit baskets for some reason. But hopefully it's pretty straightforward. And if you have any questions, then just let me know in class.